Yeah, things to do today. So for this first one here, what do we do? How do we simplify 2x times x minus 5? More specific. Yes, we need to distribute this. It's okay. You don't have to use the word distribute. We got through where we needed to get through. It's all good. I need to take this 2x times my x, and I need to take the 2x times my minus 5. So 2x times x is going to give us exactly what we said right there, our 2x squared. And when we have that minus 5 times the 2, minus 5 times 2 gives us a minus 10, and that x is still hanging out. And we cannot combine those together because those are not like terms, so this is our answer. That one's very short. The one on the right, not as short. Because this requires us to remember a smidge of geometry, just a smidge. Because how do we find the volume of a box? Length times width times height. What is the length of this box? 8x minus 3. What is the width of our box? 3x plus 4. And what's the height? X. So I can substitute those pieces into our multiplication to get the volume of this box. So if I know this is going to be length, 8x minus 3 times our width, which is 3x plus 4 times our height, which is x, we can multiply those out. We have the tools we need to that. It's what we've been working with the past couple of days. So we're going to use our box or our distributive property, either one. We're going to do 2 rounds of multiplication. You can pick whichever 2 rounds you want to do first. If you want to do our length times our width, if you want to do our width times our height, if you want to do length times the height, any of them works. We can shuffle around what order things are multiplied in. I'm just going to take it as it is because I feel like we tend to not do a ton of shuffling in what order we go. So I'm just going to go from left to right and multiply, which means my first set of multiplication is going to be these 2 things together. I'm going to give myself a little bit more space. So our first thing we're going to multiply together, we're going to take our 8x minus 3 times 3x plus 4. And we're going to use either our box or our distributive property, double distribution, FOIL, whatever we want to use to get to a multiplied out version. So we're going to have 8x times 3x. What is 8x times 3x? 24x squared. We also need to take our 8x times 4. We've got 32x. So that's my front term, that 8x times both pieces in the second. Now I'm going to do the same exact thing with my minus 3. So my minus 3 times 3x is going to give us a minus 9x. And then our last term is our minus 3 times 4, which is a minus 12. Then what we're going to do is we're going to combine our like terms together and simplify this. So we have our 24x squared, which doesn't have anything it can combine with. And then we do have a set of like terms here in our 32x minus 9x. We can combine those together. 32 minus 9 is going to give us 23. So we'll have a plus 23x, and then that minus 12 is just chilling. But remember, this is just this piece right here. This is all we did right here. So this piece is still in parentheses And then we need to multiply it by x. Because we broke this multiplication up into chunks, and I just did a smaller chunk here. So this is another distribution problem very much like this first one was. I'm going to have my 24x squared times my x. I'm going to have my 23x times x, and I'm going to have minus 12 times x. So our final multiplied out polynomial here is going to be our 24x squared times x, gives me x to the third. 23x times x is going to give us a 23x squared. And minus 12 times x gives us a minus 12x. So this is the polynomial that represents the volume of this box. Got it. Try to make sure to see everything. Questions on that one? Because it's kind of a weird way of wording one of these multiplication problems. But it is a thing that shows up every now and then. I've seen that show up on SAT before. The random polynomial box volume. So it's shown up on the practice test, it's shown up on PSAT, it's shown up on SAT. So the volume with the random polynomials is the thing that comes up in standardized tests. No, that would be a pre-cal thing. To like give it a total to work back and find a solution. That's significantly more pre-cal. I think they're going to do that next week. I'll go to a box and tell them the total volume, or the perimeter, or the surface area, something like that. Okay. So we are going to go in our notes packet. We have worked with our polynomials. We have added polynomials. We have subtracted polynomials. We have multiplied polynomials. I wonder what we're going to do next. Oh, snap. We're going to start looking at dividing. So we're going to be on page 13. And we are going to start with dividing by monomials. What that means is we are taking our polynomial, poly meaning many things, and we are dividing it by a monomial, mono, one thing. So a many thing divided by a one thing. What we're going to do when we are dividing by just a single term only, we are going to switch it from division, where it looks like actual division, to a fraction. And I know we don't like fractions, but I promise it's better. So this little example right here kind of walks you through it. They're taking this 6x squared minus 15x, and they're going to divide it by 3x. So we're going to write our division as one big old fraction here. Then what we're going to do is we're going to cut it up into pieces. So any place we have a plus or a minus, we're going to break it apart into separate fractions. So in my numerator, the one on top, any place I have a plus or a minus, I'm going to break it apart into separate fractions. Each one is going to get a copy of our denominator. And then we're going to simplify. That will be our answer. So there's a little reminder to the side. When we have variables with exponents or terms with exponents, and they're in a quotient and a fraction, just like when we have x squared times x and we multiply our bases, we're adding those exponents. X squared times x gives us x to the third. 2 plus 1 equals 3. When we're dividing them, it's subtraction. If I have m divided by n, I subtract those two numbers. So if it was x squared over x, 2 minus 1. We're going to work through this. I promise. We're going to go through a couple examples, several examples, fairly slowly, so that we can see all of these pieces. So our first example is this one. We've got our 12x to the 5th plus 24x to the 7th minus 8x cubed divided by 4x squared. the first thing we're going to do is we're going to write this as one big fraction. So I'm going to put my 12x to the 5th plus 24x to the 7th minus 8x cubed. And we want to divide by 4x squared. I'm going to write it as one big fraction first. That's how we're going to set up our division when we have just one term we're dividing by. Then we're going to cut this up into pieces. Any place I have an adding or a subtracting, a plus or a minus in my numerator, I'm going to cut it into a separate fraction there. So I'm going to split it here, and I'm going to split it here, wherever we have a plus sign or a minus sign. So this is going to turn into 3 separate fractions. We're going to have 12x to the 5th over 4x squared. We're going to have that same plus sign that's normally between the 12 and the 24 there. Then we're going to have our 24x to the 7th over 4x squared. Then we're going to have our minus sign and another fraction that has our 8x cubed over 4x squared. So step 1 is to take our written problem and write it as a fraction. Step 2, cut my fraction up into pieces. Questions on what we did or how we did there before we get to simplifying? Okay, because now we're just going to like zoom in and look at one fraction at a time. Look at this guy, blue guy. 12x to the 5th over 4x squared. I want to simplify that. How can I simplify that? What is 12 divided by 4? Right. So even if I'm just looking at those numbers, 12 divided by 4 gives us a 3, and I can simplify that bit. What's going to happen with x to the 5th over x squared? It is going to become x to the 3rd. We can either do that with going 5 minus 2 gives us 3. If that's a place that we struggle, think about x to the 5th being 1, 2, 3, 4, 5 x's over 1, 2 x's. So x to the 5th over x to the 3rd. Sorry, x to the 5th over x squared. And then this x cancels out, and that x cancels out. And we're left with just 3 x's. So it's doing the same thing as canceling out. We just don't have to write them all out that way. Let's do the same thing with our green fraction over here. The plus sign in between is still going to come on down. It's just going to chill. We've got 24x to the 7th over 4x squared. What is that going to simplify down to be? What is 24 divided by 4? 6. What is x to the 7th divided by x squared? X to the 5th. 7 x's over 2 x's. 2 of those x's are going to cross out. We're left with 5 x's there. And then our third term here. What is this one going to simplify down to be? 2 and x. Is there any more simplification we can do? No. I can't combine any of those terms together. I don't have any like terms. I've got an x next to the 5th and an x cubed. Those are all separate things. So this is our fully simplified answer. This is our quotient. what this tells us and what this is really showing is if I took, and this is not something you have to write down, I'm just going to show you guys this. If I took my 3x cubed plus 6x to the 5th minus 2x, and I multiplied it by 4x squared, we would get exactly this. So if I did this times the 4x squared, we would get exactly what we started with, that 12x to the 5th plus 24x to the 4th minus 8x cubed. It is the exact same thing. This polynomial is this times what we had left, because this is what we got when we divided that number. So we can write our results as a product. We can write our results just as an expression. We're going to write our results in lots of different ways, and I'm going to do my best to show you all the different ways we could ask you to write answers down. Most of the time, we give you blanks to fill in, but just so that we know what all the other weird things around it are. I'm going to make sure I show you all those. Questions on this first one? Because the second one next to it is very much like it. Very much like it. We've got 18x to the 7th minus 36x to the 9th minus 8x squared. And we're going to divide that by 6x to the 4th. So our very first step is going to be to write this as a fraction. We're dividing by a single term, so we are going to divide this as a fraction. So I'm going to set this up as a fraction, where we're going to have our 18x to the 7th minus 36x to the 9th minus 8x squared. And we're going to divide this by 6x to the 4th. So we're going to start by writing them as fractions. Then we need to break these apart into separate operations, separate fractions. It's going to be a lot easier to deal with that way. I'm not saying this is the only way we can do it, but it's the only tool we've got right now. So we're going to just break these up into separate pieces. We're going to have our 18x to the 7th over 6x to the 4th. Then we're going to have our minus sign, and we're going to have our 36x to the 9th over 6x to the 4th. And then we have another minus sign. We're going to have our 8x squared over 6x to the 4th. So we're going to write them as our separate fractions. Then we need to simplify each one, and we are going to be careful. We look at our purple one here. What does that simplify down to be? Yes. So 18 divided by 6 is going to give us a 3. X to the 7th over x to the 4th. 7 minus 4 is another 3. So this is x to the 3rd. Move this down a line real quick. Putting it down here. Then we have our minus sign, and we're going to look at our next one. We've got 36x to the 9th over 6x to the 4th. What's 36 divided by 6? 6 to the 5th. 5. Good. 9 minus 4 gives us 5. 9x's over 4x's will leave us with 5 that didn't cross out. But however works for you. Bless you. Here's where this one gets a little bit messy. We got 8x squared over 6x to the 4th. What's 8 divided by 6? I was say, unpleasant, right? Decimally. Yo, I don't want decimals. Leave it as a fraction. Can it simplify? 4 over 3. What happens with my x squared over x to the 4th? X to the negative 2 is what we're getting. We get our 4/3. What does it mean when we have a negative exponent? Say it a little louder. It's not imaginary, but good thought, good thought. I'm going to write over here to the side. So what if we think about it being the way we did it the first time? We looked at 2x's over 4x's. 1, 2, 3, 4.
Oh, it's dividing by itself that many times rather than multiplying.
When we have 2 that cancels out, we're left with our negative 2. What that means, if we think back to Algebra 1 when we did those, that's when it flips. This is 1 over x squared.
Can we put that in? Yes, we can.
Yes, we can. Because this is the exact same thing. Ready? Where'd you go? There's nothing here.
Oh, you saw her today?
No.
Oh, we have a French Chick-fil-A sandwich.
Poor thing. I was going to say, this is the same thing, this x to the negative 2 as 1 over x squared. So I can write this as 4 over 3x squared. You could also do it as 4/3 times 1 over x squared. Totally fine. And my question is that a polynomial? Why not? To be a polynomial, remember we had to have no x's in our denominators, no negative exponents. It's the same thing. So this one, we started with a polynomial and a monomial. We had a many things and one thing. And when we divide them, we got a not polynomial, which can happen. That is our fully simplified answer. Occasionally, we are going to wind up with fractions or answers that are not polynomials, and that's okay. That's where these things come from. These are things we will work with eventually. Yes, dear. One over that whole chunk. Okay. So sometimes our answers are not going to be polynomials. Sometimes they will be. This one was totally fine as a polynomial. We're going to practice this a couple more times. So let's look at 3 and 4 here. They've already started it for us. Aren't they nice? They wrote them as fractions this time. Handy dandy. So we don't even have to rewrite it into the fraction form. It's already there. All we've got to do now is break it apart. So sometimes we'll be given our problems as a division, like we did in the first two. Sometimes we're just going to be handed a fraction. Go team. It's already set up for us. For that one, all we need to do is kind of break it apart wherever we have an add or a subtract, whenever we have a plus or a minus. So the fact that this has z's in it doesn't change what we do at all. We've got here our 16z to the 5th over 8z cubed. And we're going to subtract our 32z to the 7th over 8z cubed. No matter what the denominator is, each one of them gets one. Good. What are we going to get when we simplify our green one over here? 16z to the 5th over 8z cubed. 2z squared. 16 divided by 8 gives me 2. 5z's over 3z's, we're left with just 2. So if I have 5 of them over 3 of them, these 3 cancel out. I have 2 left. How about for my blue one over here? 32z to the 7th over 8z cubed. It's 32 divided by 8.
That's a good question.
Yeah. 32 divided by 8 is going to give us a 4. Z to the 7th over z cubed. We can think of it as 7 minus 3. You can think of it as 7z's over 3z's, and 3 of them are going to cancel out. I could write them all out if I wanted to, but I don't want us to be in the habit of writing every single one of them out. So what if I give you one that has z to the 50? Oh. Maybe it's over z to the 40. Oh. Don't want to have to write it all out. So writing it out is a fine strategy when the numbers are small, but when we get into things that are a little bit bigger, it can be messy. So it's not a bad strategy to write it out, but use that to kind of help remember the exponent laws where we subtract. This is as far as we can go on this. This does not have anything more we can simplify. Is that a polynomial? Yeah. What degree is that polynomial? Oh, snap review. 4. It's our biggest exponent. What is the leading coefficient? -4. Good. Degree is the biggest exponent. The leading coefficient is the number in front of it. So because this is our biggest exponent, this guy's our leading coefficient. It doesn't matter that 2's the line leader. He just ran to the door early. So pulling out a little review on us. Oh, snap. Then let's look at 4. Very similar. We just got to break this apart so that we can put it into its separate fractions. So wherever we have a plus or a minus is where we split it. I'm just going to do a dotted line just because it's crashing into stuff. So I can rewrite this problem as 2 separate fractions where we have 42 t to the 9th over 7 t to the 4th. And then we have our second fraction that's going to have our 14 t to the 6th over 7 t to the 4th. I know, I'm hysterical. I'm so funny. I'm so funny. I'm so funny. I mean, we're not even the ones where I throw myself into the walls yet. We have problems where I'll do that. Not until next semester. So, we'll see. I'll do that repeatedly. For what about chapters? Because we can't crash through walls. Like the Kool-Aid Man. When we get there, you'll get it. I promise. It's okay. It's amusing, and I amuse myself. And sometimes we take the joy where we can find it. Let's simplify this one. 42 t to the 9th over 7 t to the 4th. 42 divided by 7. 6. T to the 9th over t to the 4th. T to the 5th. 9 minus 4. Or again, you can think about 9 things over 4 things. Right there. You get a snack because you signed up to donate blood. So, snacks. They're being so nice. It'll be breakfast. Because they'd like you to not pass out on them. Thank you very much. Which would be why I don't donate at school. All right, let's simplify the pink one. 14 over 7. What's 14 divided by 7? 2. What's t to the 6th divided by t to the 4th? T squared. So 14 divided by 7 is 2. T to the 2nd. Again, not anything I can simplify any further. I cannot combine together t to the 5th and t squared. They're two different things. So that's my fully simplified answer. We're going to do one more today. We're going to do number 5. And this is our last one for today. Oh, snap, look at that. This one looks kind of weird. This is a weird way we can write things down. But it's one of those things that we've seen before. We've actually seen today once, where we've got this chunk to a power of -1. What do negative exponents do again? Flip it. So this is the same thing. When we have times something to the power of -1, this piece means 1 over 3y squared. So if I'm taking this polynomial, this 9y to the 5th plus 21y to the 4th minus 12y squared times 1 over 3y squared. That's what it means when it has that parentheses to the power of -1. It's telling us that this is what we're dividing by. So times 1 over or times something to the -1 is the exact same thing as if I said divide by 3y squared. Or if I put all of this over 3y squared. It's the exact same kind of problem, just worded a little bit differently. It looks a little different. This is 100% the same thing as if I wrote this as my 9y to the 5th plus 21y to the 4th minus our 12y squared all over 3y squared. You don't have to write out all of these steps. I'm just trying to show you where this is coming from. If you can go straight from here to here, great, more power to you. If you can go straight from here to separated fractions, I am 100% okay with that. You do not have to write out all of these steps. But for some of us, it'll help us figure out where the heck that came from. Because our next thing we're going to do is we're going to split these apart into our couple of different options. So I'm going to split it apart here, and I'm going to split it apart here. Wherever I have a plus or a minus is where we split it into separate fractions. They did not think they meant it.
Again.
Ah, yes. Let's see. Over there. So splitting these apart into their separate fractions. So we're going to have our 9y to the 5th over 3y squared. Then we're going to have that plus. 21y to the 4th over our 3y squared. It's okay. We're almost there. And then we're going to have our 12y squared over our 3y squared. So we separate each of these into their own fraction. Then we're going to simplify each one. I'm going to scooch this up just a smidge so I can use that next line. Because we're about there. What do we get when we simplify our 9y to the 5th over y squared? Say 3y, 5 minus 2 is going to give us a 3. 5y to the 3rd. Or 3y to the 3rd, excuse me. What about for the green one? 21 y to the 4th. What does it say? We got 2 left to do these expressions. Not even 2 problems, these 2 fractions. 21 divided by 3 is going to give us our 7. Y to the 4th over y squared. Yep. Joanna, you raise your hand, you get a next to it. Okay, come on. So we've got our 7, we've got our y to the 4th, and our y squared. It's going to leave us with y to the what? 2. 4 minus 2 is going to give us that 2. And then our last one on the pink one. What about 12y squared over 3y squared? What do we get? 4. Because what happens to the y's? They cancel out. We get 2 minus 2. So we have y to the 0, which is just gone. It cancels out entirely. So our full polynomial answer is this guy right here. That's our fully simplified, I can't do any more to simplify an answer. Questions on these ones? What's that? When this -1 turns into a fraction and it moves this guy down into the denominator, that's when the negative disappears. The negative exponents make it flip. That's what we saw here when we kind of discovered them with our 2 over 4. We get 2 minus 4 being a -2. That's the same thing as having 2x's left in the denominator here. So the negative exponents are the same thing as flipping. Okay, so I am going to pass out to you guys homework 4. This is what we're going to be working on today and tomorrow and Monday and maybe Tuesday. So this is not due for a hot minute. It is not due until next Wednesday. So you got almost a week on it because we are going to be doing a bunch of dividing. So what we've done today is number 1. There's 2 of them up here. You could also do the review. But that way we don't get like number 1. So I'm going to pass these guys out. By the end of the week, you'll be able to do everything, including what's on the back. Kind of impressive looking.
What are the chances I'll pass out in there?
That's why they brought you a snack.
Oh, yeah. If you can make it, I mean, it's happened. I mean, I got my balloon on before, so it's not.
For the what?
That good, awesome.
Oh, I have 0 information on that.
I should think I did.
And then
I just hope they don't take
Joy.
like too much, like
this is your pass for the drive. I don't know why you keep that. Choices were made. Just so that you don't wind up missing your time.